Alright, welcome to Jaka Context. In this tutorial, I'll be putting us through how to measure staircase, how to take off for staircases. Alright, okay. Now, also, we'll be taking a reference from the NIQS test for professional competence exam. You can see this is what year is this? 2024, last year. Alright, so we'll be taking a reference from there, and then we'll see how we'll go over it, how we take off for staircases. Alright, this is a question. It says that this particular drawing, did I put the drawing reference by? Show the structural drawings of this proposed residential development to be developed in Asaba Delta State. The client wants to award the concrete work to a separate contractor and requires a tender document for this item of work. Concrete work. No reinforcement, no form work, just concrete works. In view of this requirement, prepare the taking off and draft bill of quantities for concrete work for the following. Now, because it's an exam, right? You can measure concrete only, reinforcement separate. Of course, you get, so that's what they want them to do, just the concrete, because you are doing just a takeoff. Then you prepare a draft bill. This is the question. All right, for take off quantities for staircase, floor beam, roof beam. So we'll be looking at staircase here. Then they say prepare a draft bill. We're not preparing a draft bill. I've explained how to prepare a draft bill. All right, now this is the drawing here. This is it. All right, this is NIQS. Let me put this reference. NIQS, where is it? TPC 2024 May, blah blah blah. That's what you should have it here too. Well, you know. Drawing reference. NIQS, blah 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 blah, May 2024. Let's continue. All right. So this wasn't actually what I wanted to use to explain the concept, right? It is. I had already used this particular drawing, this design, before I saw this one, right? I'd already made the video with this, the tutorial video with this, before I saw this one. So I said, okay, let me switch to this. Let me prepare this. All right. Now let's come over here quickly. All right, this is what we have. All right. It's a staircase. Staircase majorly has three major components: concrete, reinforcement, and formwork. Right? Concrete, reinforcement, and formwork are three major components. That's what you see in a takeoff list: concrete, reinforcement, formwork. You see the drawing reference is NIQS TPC blah blah blah. Our reference document is the BESMM 4R. Right? Okay, so this is basically what we have. Now, of course, let's come back to this design here. Now, this is what we have. And this is a sample of a staircase, right? Now, if you look at it very well, these are reinforcement details. Y1203 is blah blah blah. You can see them here. And we are told that this is a HL, a high level beam. Of course, this will be high. This is a high level beam. We are also given the details, right? So what this means is that this staircase is onto this wall, and this part is onto this wall. So this is where you have your landing, right? This is 1590. If you come to this detail, this is 1590. All right, so this is your landing here. Then you have your riser and tread, and of course you have the waist. Right, basically that's the staircase. All right, so we'll look at them one after the other. Now, if you come here, the landing first, concrete work in landing. Now, this is the landing here. Now you can see this landing here is not all that straight. That we can say we could just take length times breadth and then the thickness. And also, if you look at this detail very closely, you will also see that we don't know the thickness of the landing. Alright, but we know the thickness of the waist, which gives us an idea of what the landing is. The thickness of the waist is 150, telling us that okay, it will connect to this landing here, so the landing is also 150. Alright, so take note of that when we begin to calculate. Alright, now the landing, of course, this is your landing here, this is the length, this is the breadth. Now because the riser and the flight are not the same thing, you can see this flight here is longer than this. So, and that is what is represented here. This is the longer flight, this is the shorter flight. So it doesn't make this landing an easy task, length times breadth. No, so we have to break it down into two, or you take it as a whole, then you deduct. I take it as a whole, length times breadth, and then you see this portion here is not part of the landing, it's a thread. Yeah, see where my cursor is, so I have to deduct it. I think this is the approach I used in preparing this. Alright, so let's look at that quickly. This is what we have. Concrete works is in section 1.11, that's 1.11 in the BSMM 4R. So please do well, go through your BSMM and be familiar with this, especially if you're preparing for exam, the test for professional competence exam. You are not carrying Excel. You'll be carrying that big BSMM 4R and your calculator and your rule and what you'll be using to work. So please, let's get used to it. All right. Now, like I said, I already prepared this with a previous drawing. I had to just change. So let's follow through. Now this is our landing. The length is 2630. The width is 1590. See it here. 2630. This is the one I'm using here, 1590. Right? And of course, concrete is a cubic meter item. Concrete is a cubic meter cube. The unit is in meter cube. Right? Concrete is, I've explained how to use this. I even made a video for it. It's a cubic meter item. Okay, now this is this. Now if you look at this staircase here, now this dimension is at the middle, Alright, so we need to come out to give us the exact length of the staircase. That is why you see I have to less this column here, less half 230, less half of 230, less half of 230. That is what you're seeing here. Right, this is this, less 2 by half. This is half, 0.5. That is 2 by half by 230. It will still give me 230. If I less from here, I have 2400. The same thing for the width. If you look at the width, this is what we have. I have just one side of it here, so I am lessening 1. Kunjiko. Yawa. Alright, I'm lessening just 1. Here you can see I have to less 2. But here I have to less 1 to come here. This is what we have here. Alright, so basically this is what we have. 1590 less 1 by half by 230. Yeah, I'm lessing 2 by half, but here it is 1 by half. That gives me this. If I subtract, okay, I'm using 230. If I'm using 230, this should be 115. If I'm using 225, it should be 115. 112 points, so 1475. Okay, it's empty, 1.48. Alright, so this is what we have. So the length is 2.4, the width is 1.48, the depth is, thickness of the concrete is 0.15. I'm done with that. I have measured it. But of course, like I explained, if you come here, see I captured this together with it because this 1.5, see my cursor here, 1.5. See the dimension line here. This is where the peak dimension line, it has covered both this riser, so I have to deduct it. Alright, so I need to know the length of the riser the width is already known. It is shown here. This is 3000, meaning each of them is 300 times 10. 1 2 3 4 5 6 7 8 9 10. So we'll get to that. All right. Okay, now let's see how we treated, how we deducted. I put it in red to show deduction. All right. Okay, now this is what we have. This is 2400. This is 2400. All right, from here. I already come to the center. Now I need to less 50. This 50, did I name it? Is called, let's call it stair well. Depending on the size, it could be 100. All right. Let me put it as a. Let me insert comment. Let me call it stairwell. All right. This is what we have. So this 50 is stairwell. What do I mean by stairwell? Now, if you see these two, between this flight and this flight, there's a narrow line in between. If you see a staircase, that's more space between the one flight and another flight. It's called stairwell. Because if you look at it, it's going down. If you look at it from the top, right? So you have to less it. You have to less it, so that before you can now have what that is. So this is what you have after lessing it from here, 2350. Right? Now I divide by 2. I divide by 2 because this is already divided by 2. Right? I have one side, I have another side. So that's why I divide by 2 to have what the actual length of each of them is, from here to here or from here to here. Kunjiko. That is why I divide by 2. So I'm subtracting this from there, 1.18, which is this, by 0.3, which is the width of the thread, which is the thread, by 0.15, which is the thickness of the landing that we used there. All right. So that is it. This is one way to do it. Another way to do it is just to make sure you divide everything into 2, then you take it separately. Right? So just divide it into 2, then treat it separately. That's another way. Just instead of me taking it 1, I just from the beginning, the 260 coming inside by lessing 2 by half, then remove stairwell, then divide by 2. Then you can now say whatever it is times this side, then you treat this side also separately. So whichever way you want to do it, it is your choose. All right. Now, not every staircase is like this, right? But of course, some of them are like that. Take for instance, see the one I used before. You can see they are the same thing, right? They are the same thing. So I don't have to start saying dividing a landing into 2 or lessing one that is not because they are not of the same length or the same width and all, right? So this is the same thing. I will not be going through the root here. Yeah, I'll just do length times breadth times thickness because the flights are the same thing. But here, they are not the same thing. And of course, that is what your examiner wants to see, how you are going to do it, how you are going to treat it. All right, that's that about the landing. The next is the waist. The next I treated here is the waist. This is the waist of this staircase. Here, Eba Noah is the waist. Here is also the waist. My Igbo college is the west. The west. All right, this is the waist. Okay, this is the waist of this also. So now we need to calculate the waist, but of course you need to know what the length of this waist is before you can calculate it. Now, if you observe very well from here, you may not know, one may not know how to, because we're not told. Now, look at this drawing here. See, we're given this, the height of this. We're told that 11 equal risers at 175. The same thing here, 11 equal at 175. So by the time you multiply 11 by 175, you're having 1925. It tells you here is 195. Automatically here also is 1925. So that you're going up or you're coming down. The same thing here, here is 1925. Alright? But our drawing in consideration, we don't have it. They didn't give us that information. So we need to find a way to calculate it. So I needed to go through this route so that you will understand better when it is not given. How do I go about it? Alright? Now, there is one way is this, for me to know the length of this waist. In this calculation, I resorted to Pythagoras. Okay? Now this is how it went. Now, I have 10 treads. What I mean tread is where you put your, if you're matching a staircase, where you put your leg is called the tread. Why the riser is that the vertical one, then the tread, then the riser. I have 10 risers here. 10 tread. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now for every 10 tread, you're going to have 11 riser. Let me show us see an clear example here. Say here we have 10 equal tread. We have 11 equal riser. Right? So if I have 9 treads, I'm going to have 10 risers. If I have 8 treads, I'm going to have 9 risers. Okay. Now, here I have 10 treads, so I'm going to have 11 risers. That is one way. I'm going to have 11 risers. So, and each thread, each riser, were not given. Right, but in this drawing, I assumed it to be 175. Did I? 175. See it here. I assume 175. That, of course, because it's an exam. But see this drawing now. This is a drawing for a job, actually, right? See, if I use one, I won't be going through all this stress. But I needed to see from different perspective. Right now, we already know the riser. We already know it's 175. But here, we don't know because we were not told. So we took it to be 175. That's an assumption. So in an exam, whatever assumption you make, you note it down. I hope it's clear. Alright. So 11 risers times 175. I should be having 1925. That's what I have here. 1925. See it here, 11 times 175. So what it means is, I know now from here to here. The same way this is up here. This is the bottom part of it. Okay? This thing is drawing up. Okay, this is the bottom part of it. Down this way. Alright. So that now it will give you this shape. Don't mind the fact that it's facing this side, but it is facing this other side. Alright. So this will form a right angle triangle with this point here. That is what I have here. It is to form a right angle triangle. This is the height, 1925. Now this is the riser part, the tread part, 3000. I already explained that 3000 before, right? This is the horizontal distance. It is 3000, and I've said that is 3000. You can do it on any staircase. Count the number of treads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of them. That means this thread is 300. Though we're not given, but it is 3. We know it's 300 because this is 3000. Right? 3000 divided by 10 is 300. So you can, if you're not given the thread on any staircase, just count the number of thread. Right? Count the number of threads. You already know what it is. All right, let's forge ahead. So from here now, I'll calculate this using Pythagoras. I already explained Pythagoras before. Pythagoras theorem states that the hypotenuse is equal to the square root of the sum of the squares of the other two sides. So the square root of the square of this plus this. This is what I explained here. Is the square root of the sum of the squares of the other two sides. So this is what I have, 3.56. So this is 3.56. All right. Now I already calculated the width of the waist when we did this calculation here, when we got this here. This is one. This is another one. Right, so there are two. So this is what we'll have. 3.56 is the length, which we just calculated. The width is 1.18, which we calculated here. While the thickness is 150, and of course you can see clearly there. We're told that this is 150 mm. All right. So now for the other part of it, this is one part. Now the second part, which is the shorter part. All right, I want us to look at it very closely. Now this is an exam question, so that is why it is not straightforward. So let us see what is missing now. From this explanation we did here, we want to bring it up here also to see if it will give us the same thing. Now let us see it. See what I'm explaining. I want to count how many threads are here. How many threads are here? Count with me. Let's go. 1, 2, 3, 4, 5, 6, 7. It is 7. And we are told that each thread is 300. Because this one cannot be 300, this one will be 120 or 150. They have to be the same thing. Now it is 300. So 300 times 7 is what? 21. 3 times 7 is 21. So that's 2,100. But what we have here is 27. Exam. Again, they want to test your understanding. If this is 27, then this will not be 7. This should be 9. Because it's 3 times 9, that will give you 27. I don't know if somebody is following me. Ununa water. Alright, now because this is an exam, so they want to test you to know if you don't know that something is wrong, you will not know. And you will get 0. Alright? So please. So this will not be 7, it will be 9 because this is 27. 3 times 9, that will give you 27. Alright, so we have 9 threads. If we have 9 threads, we are going to have 10 risers. We are going to have 10 risers. Alright? Okay, so you can see what I mean by riser here. This vertical one, this one, this one, this one, this one, this one. Alright? Now see the threads. 1, 2, 3, 4, 5, 6, 7. Let us count the riser. See this thread. See one riser. 1, 2, 3, 4, 5, 6, 7. Okay. See here. This is another 1, 2, 3, 4, 5, 6, 7, 8. So if I have 7 thread, I should have 8 riser. But of course, remember this thread is not, according to our calculation, it is not 7, no. It is 9. So if we have 9, we have 10 risers. I don't know if it is clear. Or by the time you go over the video second time, you get it better. Alright, now let's come over to the Excel sheet. Now this is its own here. Right. So this is the riser now, 10 of them. 10 times 175 is 1750. Now this is not 2. This is, remember here it is 27, but we just established that it is not 27. It should be 29. It's an exam question, so your examiner wants to know if you know what you're doing or what you're not doing, or you don't know what you're doing. Koban Kabani. Yowa. Okay, this is what we have. So I do the same thing for Pythagoras, right? So square root of the square of this and this, the summation of the square of this and this, that gives me 3.3387.11. That's what you see here, 3.39 in my dimension column. I already know this one, which is 1.18. This is 0.15. This is staircase waist too. Oh yes, the second side of the waist. Oh, all right. So this is okay. Okay, I think I wrote it here. Note, the horizontal is 27, but thread is 300. Total thread should be 27 divided by 300, which is 9. All right, and not what is obtainable there. So for every 9 thread, there will be 10 risers, not 11. All right. So this clears it. All right. So we are done with the waist. Now this is taking time because of the way the question is. If it were here, assuming it's this one we're working with, they are the same. To just multiply by 2 straight away. Just calculate 1, multiply by 2, because from here they are the same thing. But it is not like that often, like what we are seeing in this particular question. So you need to take notes. That is why it is taking time. I'm taking my time to explain it. All right. The next item is the riser and the threads. The riser and the threads. This is what I have. Now, of course, this is in triangular form. This is it here. I just see this thing here. I just brought out one. This thread riser. I just brought out one. See the shape is the shape of a triangle. I just brought out one. This is what I have here. 175 by 300. Right? Also, for me to know this, to calculate the concrete here, I use Pythagoras to know what this length is. This is a form of a triangle. We're going to treat it with the area of a triangle. Alright? That's what it means. So this is what we have. Okay. If I do the calculation, I have 347.31. That's 0.35. That's what we have here, 0.35. We know the triangle is 1/2. Let me put it somewhere. Area of triangle is equal to 1/2 times base times height. Right? 1/2 times this base now is talking about this. The height is the slant height now, not this height, but the slant height. Right? So this is 0.35 times the base, which is the base is not 0, is the base is 0.3. This is the base now, times the slant height. 0.35, which is a slant height, or 1/2 base times height, the same thing. Okay, the base is 0.30, the height is 0.35, right, which is a slant height times the length of that particular thread. The length of that particular thread, that is the length from here to here. So that's what we have. So it is, see, times half, because it is, we have 10 number altogether threads times 0.5. The same thing goes for the other flight also, because they are not the same thing. It will give us the same thing. This is 0.3. The only difference is the number of flights is different. the number of flights is different. Now this is 10, while this is 9. All right, this is 10, while this is 9. However, it is it was 4 point something, so it round it up to 5. How did I do it here again? It was oh, we have 9 numbers. 9 numbers times 0.5 will give you 4.5. Right? So 4.5, I took it up again to 5. That is why you're seeing 5 here. Right? One is 10 number, the other one is 9 number threads. Right? So that is why you're seeing 5 here. Alright? So this is how you calculate the concrete for the riser and the thread. Remember, they are not the same thing. If they are the same thing, it would have been way much easier. Now, also, if you come here, you see this. There's a high level beam. As this beam is at a higher level. All right. So this is what we have here. We know this. We know the length. We know the reinforcement inside, and all. So we calculate the concrete also. And this is the high level beam here. Right. Of course, I need to come outside like we did here. That's the same thing there. I just repeated it. Right. So this is 2.4 by 0.33. The depth is 0.45. How do I know? See it here. It's not magic. 450 by 230 by 450 by 230 high level beam. That's high level beam 2630. So this is the concrete. Right? Now, reinforcement. Now, remember we said staircase is concrete, reinforcement, and formwork. Now, see, for this exam, since you're measuring concrete, the assumption will be that you use factor for the reinforcement. You will use factor for the reinforcement. What I mean by factor? It means that you will use maybe 75 kg per cubic meter, or use 100 kg per cubic meter, or 120 kg per cubic meter. You will not have to calculate. If it's an exam situation, you don't. I say you are told to calculate, to take off for reinforcement. You don't take off for reinforcement. And I think the reason is because they believe it's taking time. It takes time. But for the purpose of this tutorial, I will not be using that factor. I will show us how to measure it. Right? Even if I'm making assumptions too, but you have an idea how to measure it if you have it as a job. All right. Now let us see. Now in this case, I didn't use this drawing to do it. Let me tell you why. Now one is not too clear compared to this one. And you can see how sharp this one is. Everybody can see it. I'll tell us another thing again. This is just white. See this, for instance, Y1206 at 200. How many Y12? How many? Right? We don't know. Now let me tell us why we don't know. Okay, let's come here. Take this one, Y1205. It is more clear. Y1205 at 200. If you trace it, look at where this dot is. Right? Look at it here. See this dot. See this here. This is the reinforcement. Now we cannot see the span. What I mean by span? Span is, if this is this reinforcement here, where will it cover? From where to where this particular reinforcement will cover? Now let me show us what it means here. Here I'll pick any reinforcement. This is, look at this reinforcement here. 17Y1205. 17Y1205 at 150 center top and bottom. Right? And this is all we have. Trace this arrow to where you see the black dot. This is the black dot. This is the reinforcement he's talking about. Now, you see this arrow here and this arrow here is called the span. It means this reinforcement here will be here. It will cover all this place. That is why you see one at 150 mm spacing, center to center. One will be here, another one, another one, another one, another one. They will fill this place here. 17 numbers, top and bottom. I will explain something here again. If it were to be 30 top and bottom, and this 17 means top and bottom. If not, they would have put 34. Except the structural engineer gives a further instruction. Don't say it is top and bottom, you multiply by 2. I don't know if I got that right in Igbo. Nobody sent you. The structural engineer will put it 34. Top and bottom is 17. Don't go and help them and put 34 without a request for information. Alright, so let's go. I use this actually to prepare the reinforcement. This is what I use to prepare the reinforcement. Alright, so I just showed you how you calculate it. Alright, so this is 17Y1205. Okay. 17 is the number of reinforcement. 17 is the number. Y is the type. Y means high yield. M or S means mild steel. Y is the type. Y means high yield. If it is M, it is S, which is very scarce or rare. It is mild steel. 12 is the diameter of the bar. It could be 12, it could be 16, it could be 10, it could be 20, whatever. Here it is 12. It is 12. So this is the diameter of the bar. 05 is the bar mark. Reinforcement, they come with different bar marks. Right? Each bar has their different, what do you call it? Batch of reinforcement have their different bar marks. So this is 05. Art is art. You know that one. 150 is the spacing. C to C is center to center. T and B means top and bottom. Enunana. Koban Kabani. Yawa. Alright. So this is basically what we have. And I will just show us. I will not take my time because it will take time to start, but I'll show you. Now I pick this one for instance. Now let me take the assumptions I made. This is C. 1050, right? So I only have this small place here and this small place here to deal with. So I just assumed, but of course, if you're working practically, you don't assume. If you have the drawing on paper, you scale it. You either scale it, these little parts, or you use either Plan Swift or Bluebeam to get the actual dimension. Alright, I cannot go switch now to Bluebeam or Plan Swift to begin to do that. Alright, now if I pick this one, 17Y1204, just trace it to where you have the black dot. Bam, see it here. This is the reinforcement it is talking about. And this is the span. From here to here is the span. Means this reinforcement, I'm going to have it all here. 17 numbers. Alright? And if I want to find the dimension, if it is not stated categorically, it's either if you have the drawing on a sheet, you scale it, or you use Plan Swift or Bluebeam to arrive at the actual length. Of course, if you know how to use Plan Swift, and you should know how to use Plan Swift and Bluebeam as a quantity surveyor. Alright, so that is how all these reinforcements were obtained. Right? This is it. Okay, let's pick. This is 17Y1201, center to center, top and bottom. 17Y1201. Let's look for it. 17Y12 01 or 05. 01. Okay, this bar mark is 01. Okay, look at it here. Look at it here. This one. So let's see how I did it. Let's trace it to the black dot. Bam. See it here. Alright. Now this is the reinforcement we are talking about. Now this is the span. Look at this black arrow to this black arrow is the span. And we're told there are 17 numbers, top and bottom. Alright. This is 945. From here to here is 945. All I need to do is to add this small one here and add this small one here. Let us see how I was able to do that. See, 945. I added 200, then I added bent. You see? So I will not be far. I will not be far from the actual dimension now because I am solving an exam question. Alright, but if it were for reality, I'm working on a particular area, I won't do it like that. I either go to Bluebeam or Plan Swift. I'll scale properly, then I'll get the actual dimension because the dimension given doesn't cover all the parts. I hope we get that straight. Alright, so this is what I did here, multiply by 17 because we are already at 17 numbers. That's why you have 2740. So the same way we do for each of all the other reinforcements. So at the end of the day, we add them up together. That's 20. This is 225.122.26. All right, and this is a 12 mm diameter high steel bar in structures. All right, 12 mm has a conversion factor of 0.888. Remember, it's in tone. You have to show it in tone. If this is not there either, right, you have missed it because you only told your examiner you only put it in length. You didn't convert to tones. Multiply by 0.888 puts it in kg. I've explained that concept before. But if you divide by 1000, it shows you have taken it to tons. All right, so please let us take note of that. So I didn't use this one because one, it is not clear. We didn't know how many bars are there, and we cannot see the span. So if we can see the span clearly, then we'll be able to estimate the number of reinforcement that will be in each span given any reinforcement. All right, I hope we get that straight. All right, let's go forward. Of course, the high level beam also has reinforcement. We need to calculate it. Right, which is what is calculated here. All right, 2.43. The same thing, we need to calculate the links. All right, the beam is 230 by 450. All right, so of course that means you know what links are, stirrup that tie the beam, right, at different center to center. Okay, all right, so this is basically what we have here. Now let's cover and then we add bend, because if you must see the reinforcement inside, you must see the stirrup, you need to let's cover. The same thing here, right? The same thing I did here. For me to see it, for calculating the length of the reinforcement, I have to let's cover, I have to add bend. The same thing, you let's cover, then you add bend. We're not giving cover and bend in that particular question. This cover and bend is now an assumption because you'll be told to make reasonable and necessary assumptions. Kunjiko, you'll be asked to make reasonable and necessary assumptions. So that is what I have there. So this is 1160 for the stirrup. This is 1.16. 14 numbers. Total length is 2630 divided by 200 plus 1. That's the spacing. See it here. I didn't manufacture it. See it here. See it here. Our total is 14 numbers. You see this one is 14 numbers. This is 2 numbers. Did I actually do this? 2 numbers. So that should be. Did I? Oh yes, I did. All right. So this is what we have, 14 numbers. I did this to confirm if it was actually 14 numbers. All right. Having done that, we've done concrete, we've done reinforcement. Now it is the formwork. Of course, everywhere you have concrete, you are going to put formwork. Otherwise, your concrete will not stand. It is the formwork that makes the concrete to stand. Koba and Kaba, Toho and Kani. Even the reinforcement that is there without the formwork will not sustain the concrete. So it is the formwork. That is how important the formwork is. The formwork is as important as the reinforcement. Otherwise, the concrete will not still stay. Okay. So, of course, all what we have done concrete for, we'll put reinforcement. The landing, the waist, the riser and the step, riser and thread, the beam. We're going to put reinforcement. We're going to put formwork in all of them. Okay, so this is basically what we have here. This is our landing, 2.4 by 1.48. Of course, you know that formwork is a square meter, is a meter square item. Is a meter square item, right? To landing. Now, of course, I have to deduct that small part, just the same way I did here. I have to deduct it. Now this will no longer be by 2. This is from the previous drawing. Alright, of course, the edge of the landing. Now you see these two landing here. One is going up. This is going, which one is even going up, safe? Okay, the short one is going up. The short one, this is coming from down. This is going up. Alright, so in between them here, in between them at some point, how will I explain this now? That point where one is going up, one is coming down. We have to form, as you put formwork at the bottom of the landing, you need to put formwork at that point too. There's no way I can explain it here. Somewhere here, right? Somewhere here, like somewhere here, where one is going up, another one is coming down. Just use your mind and visualize it. You see what I'm talking about? Or you go and look at the staircase in your house. All right. Okay, so that is why you see this here. This 2.4. Right? Just about the length of this. Somewhere you have your landing, where this one is coming and where this one is going up. At that point. All right. Now the same thing. And now, of course, you can see the BSMN 4R references. The references are there. I will always put the references for easy referencing whenever you want to check on them. Alright, so that's why I say edges of horizontal work are down the waist. The waist we calculated, if you see, I didn't see. Just come here. There's no point trying to double over it. This is the length times width is the waist. I just pick it. Length times width is the weight. I just pick it. That is where I want to put formwork. Alright. Now, the same thing to the side of the waist. The sides of the waist. Alright. This is it here. This side. This is your waist here. I need to cover the side with formwork. That's what I mean by side. And of course, one at this point here. One for this one. One for this one. Right? So that is why you're seeing it like that. This is 3.56, which is the longer one. 3.39, which is the shorter one. The same thing now for the riser and for the thread. For riser, you know the thread is where you are going to put your leg. You can't cover it. You can protect it. So, but the one for the riser, you have to put your formwork. This is what I have here. Now for the two of them, 11.10. Now let me explain what I did here. 11.10 is not 11 times 10. In mathematics, 11.10 in mathematics is multiplication. But in quantity surveying, 11.10 means 11 plus 10. You should know that by now as a QS. Dot means plus. Ibako. You understand? So 11.10, I didn't make any mistake. It means 11 plus 10. For the first one you have 10, the other one you have, the longer one you have 11, the shorter one you have 10. Okay, let me leave it there. The same thing here for the riser and the thread. all these points here, this triangle here, you have to cover it. You have to cover it. You have to cover it. It is not the same thing as that of the waist or the edges of the waist. Hadiche, they are very different. One yato. Alright? Okay. So that I just, the same thing we did here. If you come to riser and thread, I just picked it from there. Riser and thread. Where is this riser and thread? The same thing. At 0. The slant height 0.35 by the base, which is 0.3. That means, let me come back here. 0.3 is not 0.33. 0.33. Did I get 0.33 anywhere? Okay, 0.35. Alright, this is 0.35. Right? Which is the slant part of it. Which is the slant part of it. Which is here by this. That's what will give us, that's what will cover that place properly. This is 0.3. Okay, so this is it. Right, let me close it. So this is how you measure a staircase. Now you can see we've done for concrete, we've measured reinforcement, we've measured the formwork. Right, but the question didn't say we should do all this, but for the purpose of learning, I've taken my time to explain this so that we get a better understanding of it. Right, so this is basically how you measure staircase, how you take off for staircase. I hope this helps you academically, it helps you in your career, it helps you in your next job as a professional. I'll see you guys in the next video. This is Chaka Quantics. Thank you.